everyone, welcome back to my channel. In previous videos, we studied about second module, Differential Calculus 2. In this video, we study about module 3, that is Ordinary Differential Equation. To understand the concept of ordinary differential equation, first let us understand what is differential equation. Definition of a differential equation says, an equation in which independent variable, dependent variable, differential coefficient of dependent variable with respect to independent variable are involved is called differential equation. Let us suppose y is equal to f of x be a function. Here for every value of x we get a value of y. So that x is an independent variable, y is a dependent variable. Let us take some example for differential equation. Here these are all a differential equation because in this equation, this contains independent variable x, dependent variable y, and the differential coefficient of dependent variable with respect to independent variables are involved. So these are all the examples of differential equation. There are two types of differential equations. One is ordinary differential equation and another one is partial differential equation. Simply we can call this as ODE and PDE. ODE is nothing but ordinary differential equation. PDE is partial differential equation. Let us see what's the definition of ordinary differential equation. An equation is said to be ordinary differential equation if the derivatives involved in it are with respect to single independent variable. Let us take some example and explain. Here 1 plus dy by dx whole square whole power 3 by 2 which is equal to d square y by dx square. So this is an example for ordinary differential equation because this is an equation which contains only one independent variable. Here this is an equation containing independent variable x. Here x is an independent variable. So this is an example for ordinary differential equation. That is, the definition of ordinary differential equation says an equation is said to be ordinary differential equation if the derivatives involved in it are with respect to single independent variable. Here the derivatives are dy by dx, d square y by dx square. So this contains a single independent variable x. So this is a ordinary differential equation. Let us take another example, d square y by dx square which is equal to minus a square into x. Here also the equation contains single independent variable x, that is derivatives of single independent variable is nothing but an ordinary differential equation. Let us see what is the definition of partial differential equation. An equation is said to be partial differential equation if the derivatives involved in it are with respect to more than one independent variable. If there is a single independent variable, that is an ordinary differential equation. If that is more than one independent variables are present in the equation, then we can call that equation as partial differential equation. Let us take some example. X into del z by del x plus y into del z by del y which is equal to 2z. This is an example for partial differential equation. Always the partial derivatives are denoted by the symbol del. We already discussed in the previous videos about partial differential equation. So this is a partial differential equation because it contains more than one independent variable. Here the dependent variable z depends on two independent variable x and y. So it contains the derivatives involving more than one independent variable, that is del z by del x, del z by del y. So this is a partial differential equation. Similarly we have del square u by del x square minus a square into del square u by del y square which is equal to 0. This is also an example for partial differential equation because the dependent variable u depends on two independent variable, that is x and y. So this is the example for partial differential equation. Next we shall see what is the definition of order and degree of differential equation. The highest order derivatives present in the equation is called order of the differential equation. To find the order of the differential equation means the highest order derivatives present in the equation is called as order of differential equation. Also, the positive integral power of highest order derivative involved in it is called degree of that differential equation. Let us see what is order and degree of differential equation with an example. Here is an example 1, that is 3x minus 4y into dy by dx plus 7y square plus 6y which is equal to 0. Here we have supposed to find order and degree for this differential equation. Firstly, this is a differential equation because it contains independent variable x, dependent variable y, and the differential coefficient of dependent variable with respect to independent variable. So this is a differential equation first. Again, to find the order and degree means order is nothing but highest order derivative present in the equation is called order of the differential equation. To find the order of the differential equation means that is highest order derivative present in the equation is nothing but the order of differential equation. So this is a differential equation contains dy by dx. So its order is 1. It contains only dy by dx value. So its order is 1. Similarly, the positive integral power of highest order derivative involved in it is called degree of that equation. First, we have to find the order of this differential equation. For that, here dy by dx, here order is 1. The highest integral power of that highest order derivative, that is dy by dx to the power 1. Here also 1. Hence, we can conclude that order is equal to 1 and degree is equal to 1. For this equation, order is 1, degree is 1 because it contains highest order derivative, that is dy by dx. Hence, we can conclude that its order is 1. The positive integral power of that highest order derivative is dy by dx whole power 1 itself. So, we can conclude that order is 1 and degree is 1. Take another example. 1 plus dy by dx whole square whole power 3 by 2, which is equal to d square y by dx square. Here, to find the order and degree of differential equation, first you have to note the highest order derivative. But in this case, in the left hand side of the equation, we have 1 plus dy by dx whole square whole power 3 by 2. Here, no particular orders here. So, to obtain the particular order, squaring on both the side of the equation, in the left hand side we get as 1 plus dy by dx whole square whole power 3 by 2 multiply with 2. Hence, we can cancel these two terms and the remaining is 1 plus dy by dx whole square whole power 3, which is equal to, in the right hand side, d square y by dx square whole power 2. Now, we can conclude that here in the left hand side we can simplify further as this is of the form a plus b whole cube, so that we get a maximum value as this is dy by dx whole square. Hence, we get the maximum value as dy by dx whole power 6. So, to find the order of the differential equation, first you have to note that the highest order derivative present in the equation is called order of a differential equation. So, we can easily conclude that here highest order derivative for the equation is d square y by dx square. This is a highest order term. Hence, it contains an order 2 and the positive integral power of this highest order derivative is 2 itself. Hence, we can conclude that order is 2, degree is 2. This is the procedure to find order and degree of differential equation. Next, we shall come to the actual concept in module 3, that is differential equation of first order and first degree. The general form of first order and first degree equation is given by f of x, y, dy by dx, which is equal to 0. This is a standard form of first order and first degree equation. Our aim is to find the solution for this first order and first degree equation. So in general, the solution of this equation is of the form f of x, y, c, which is equal to 0, where c is an arbitrary constant which satisfies this equation. F of x, y, dy by dx, which is equal to 0. For this, the general solution is given by the form f of x, y, c, where c is some arbitrary constant. We consider some standard forms of equation, one which can be solved by following standard techniques. To obtain a general solution for this first order and first degree equation, we have standard rules. Using that rules, we can find the solution for the first order and first degree equation. Here, first technique is variable separable form and reducible to variable separable form. Second one is homogeneous equation and reducible to homogeneous equation. Third one, exact equation and reducible to exact equation. And fourth one, linear equation and reducible to linear equation. We can call this as Bernoulli's form. So these are all the four techniques. With the help of these techniques, we find the general solution for the first order and first degree equation, that is f of x, y, dy by dx, which is equal to 0. In particularly, in this module, we study about exact differential equation and reducible to exact differential equation, linear equation and reducible to linear equation, that is Bernoulli's form. Let us see one by one. In this video, we study about exact differential equation first. Here, definition of exact differential equation says, a differential equation of the form m dx plus n dy, which is equal to 0, where m and n are the function of both x and y, is said to be exact if there exists a function f of x comma y such that d of f which is equal to m dx plus n dy, and hence solution is f of x comma y which is equal to 0. Here this is a definition of exact differential equation. So the differential equation is of the form m dx plus n dy which is equal to 0. Here this is the standard differentiation formula of exact differential equation, that is m dx plus n dy which is equal to 0. This is an exact differential equation where here m and n terms are the function of both x and y. Here m and n are function of x and y, which is said to be an exact. If this equation is said to be an exact means if there exists a function f of x comma y such that its derivative of a function, that is m dx plus n dy's derivative, and hence the solution is given by f of x comma y which is equal to 0. Let us see working rule. It is to find the exact differential equation. What are all the working rules? Let us see. Step 1. Write the given differential equation of the form m dx plus n dy which is equal to 0. Here the equation will be of the form m dx plus n dy which is equal to 0. In the second step, identify m and n. After obtaining m and n, find del m by del y and del n by del x. Here del m by del y and del n by del x are partial derivative of m with respect to y and partial derivative of n with respect to x. After identifying m and n value, we have to find del m by del y and del n by del x. Step 3. If del m by del y which is equal to del n by del x, we say that the given differential equation is exact differential equation. Here, working rule to find the exact differential equation means first you have to consider the given differential equation of the form m dx plus n dy which is equal to 0. After taking this value, identify m and n value from this equation. Then find del m by del y and del n by del x. After finding these two equations, equate these two equations. If the equations are equal, then we can conclude that the given differential equation is exact differential equation. Also, we have to find the solution for this exact differential equation. In the next step, to find the solution for the exact differential equation is formula is given by integral of m of x comma y into dx plus integral of term which does not contains x in n into dy which is equal to 0. This is a standard equation. To find the solution for exact differential equation, you have to remember this formula. That is, to solve the problems related to exact differential equation, we must know some basic integral formulas. So this is a procedure to find the exact differential equation. Let us solve some problems related to finding exact differential equation so that you can understand in a better way. Here is the first problem. Solve dy by dx plus 2x plus 3y minus 1 divided by 3x plus 4y minus 2 which is equal to 0. Here in the examination, they do not give directly solve exact differential equation. Instead, they give problems. You must conclude the given differential equation problems are exact differential equation or not and solve the problem. So this is a problem. In the first step, we have to reduce this equation to exact differential equation. For that, cross multiplying these two equations we get as 2x plus 3y minus 1 into dx plus 3x plus 4y minus 2 into dy which is equal to 0. Here cross multiplying these two equations we get the exact differential equation of this form. After obtaining exact differential equation, take m and n value. Here m value is this m dx plus n dy which is equal to 0. So m is 2x plus 3y minus 1, n is 3x plus 4y minus 2. This is m and n value. After identifying m and n value, what is the next step? Find del m by del y and del n by del x. Not del m by del x, del n by del y. Observe carefully, we have to find del m by del y and del n by del x. Del m by del y is nothing but partial derivative of m with respect to y. So the partial derivative of m with respect to y is, here no y term. Here we have 3y. Here 3 is constant, take as it is, into differentiation of y is 1. Hence we get del m by del y value as 3. Similarly, del n by del x value as, here differentiation of 3x is 3. Here no x term. Hence we get del n by del x value is also equal to 3. Hence we conclude that del m by del y is also value is 3 and del n by del x value is also equal to 3. Hence we can conclude that del m by del y which is equal to del n by del x. If this is a case, then the given differential equation is exact differential equation. Here By the equation del m by del y, which is equal to del n by del x, we can conclude that the given differential equation is an exact differential equation. Once we have identified if this is an exact differential equation, next step we have to find the solution for this given differential equation. For that, the formula is given by, that is, solution for exact differential equation is given by integral of m of x comma y into dx plus integral of terms which does not contain x in n into dy, which is equal to 0. Here solution for the exact differential equation is given by integral of m of x comma y into dx plus integral of terms which does not contain x in n into dy, which is equal to 0. Substituting these values here, we get as integral of m of x comma y, that is, m value is 2x plus 3y minus 1 into dx plus integral of, meaning of this is terms which does not contain x in n. That means we have to consider n value here which does not contain x. Here we have x term, so we have to neglect this value. Here no x term, here also no x term. So in the place of this, we have to write integral of 4y minus 2 into dy, which is equal to 0. Observe carefully. In the first integral, we have to substitute m value, both x and y values in m. In second integral, we have to exclude the terms which contain x in n, that is 4y minus 2. We have to integrate this value with respect to y, which is equal to 0. Here integration of 2x is 2 is constant, take as it is, into integration of x is x square by 2 plus 3y is constant, take as it is, into integration of, here nothing is present means 1 is there, integration of 1 is x minus integration of 1 with respect to x is x plus, here also we have to integrate this term 4y minus 2, we have to integrate with respect to y here. Here 4 is constant, take as it is, into integration of y is y square by 2 minus 2 is constant into 1, integration of 1 with respect to y is y, which is equal to c, some arbitrary constant c. In next step, here 2 gets cancelled, here 2 1s are 2 2s are, the remaining is x square plus 3xy minus x plus 2y square minus 2y, which is equal to c. This is a solution for the given problem dy by dx plus 2x plus 3y minus 1 divided by 3x plus 4y minus 2, which is equal to 0. This completes the problem. We shall move on to another problem so that you can understand in a better way. Solve 5x power 4 plus 3x square y square minus 2xy cube into dx plus 2x cube y minus 3x square y square minus 5y power 4 into dy, which is equal to 0. In this problem, they have given directly the differential equation of the form m dx plus n dy, which is equal to 0. So the given differential equation of the form m dx plus n dy, which is equal to 0. Hence we can take m and n value as this, that is m is equal to 5x power 4 plus 3x square y square minus 2xy cube. This is our m. Similarly, n is 2x cube y minus 3x square y square minus 5y power 4. After finding m and n value, we have to find del m by del y and del n by del x. Here del m by del y is partial derivative of m with respect to y. Here no y term. Here we have y term. Here consider 3x square as constant into differentiation of y square is 2y. Hence 2 into 3 is 6x square y minus, here 2x is constant, take as this, into differentiation of y cube is 3y square. 3 into 2 is 6xy square. This is del m by del y. Similarly, find del n by del x as, here 2 into y is constant, take as this, into differentiation of x cube is 3x square. Hence we get 3 into 2 is 6x square y minus 3y square is constant, take as it is, into differentiation of x square is 2x. Hence 2 into 3 is 6xy square. Here no x term, so neglect this value. Hence we get del m by del y value and del n by del x value, which is equal to 6x square y minus 6xy square. Therefore, del m by del y, which is equal to del n by del x. This concludes the given differential equation is exact differential equation. Once we conclude the given differential equation is exact differential equation, we have to find the solution for the exact differential equation, which is given by integral of m of x comma y into dx plus integral of terms which does not contain x in n into dy, which is equal to 0. Substituting these values here, we get as integral of m value is this 5x power 4 plus 3x square y square minus 2xy cube into dx plus integral of terms which does not contain x in n Here we have n term is this. Terms which does not contain x means here we have a x term, so neglect this value. Here also we have x term, so neglect this value. The remaining is minus 5y power 4. We have to consider the negative values also. N is minus 5y power 4, which is equal to 0. Now integrating with respect to x and with respect to y, we get as, integrating this equation with respect to x and with respect to y, we get as, here 5 into integration of x power 4 is x power 5 by 5 plus 3y square is constant, take as it is, into integration of x square is x cube by 3 minus 2y cube is constant, take as it is, into integration of x is x square by 2. Here plus into minus 5 is constant, take as it is, into integration of y power 4 is y power 5 by 5, which is equal to some arbitrary constant c. Next step, cancelling the values, we get as, here 5 gets cancelled, here 3 gets cancelled, here 2 gets cancelled, here 5 and 5 gets cancelled. The remaining is x power 5 minus y power 5 plus x cube y square minus x square y cube, which is equal to c. This is a solution for the given differential equation. This completes the problem. Let us take some another problem. This is very important question paper problems. They asked so many times in examination. Solve dy by dx plus y cos x plus sin y plus y divided by sin x plus x cos y plus x, which is equal to 0. First step, rearrange as m dx plus n dy, which is equal to 0. That is, cross multiplying values, we get as y cos x plus sin y plus y into dx plus sin x plus x cos y plus x into dy, which is equal to 0. What's the first step? Take m and n value. M is y cos x plus sin y plus y. N is sin x plus x cos y plus x. Next step, find del m by del y and del n by del x. Here del m by del y is partial derivative of m with respect to y. Here cos x is constant, take as it is, into derivative of y is 1 plus differentiation of sin y is cos y plus differentiation of y is 1. Similarly, del n by del x is partial derivative of n with respect to x. Here differentiation of sin x is cos x plus cos y is constant, take as it is, into differentiation of x is 1 plus differentiation of x is 1 here. So we get del m by del y and del n by del x. Observe carefully, del m by del y value is same as that of del n by del x. Therefore, del m by del y value, which is equal to del n by del x. This concludes the given differential equation is exact differential equation. Once the given differential equation is exact differential equation, the solution for the exact differential equation is given by integral of m of x comma y into dx plus integral of terms which does not contains x in n into dy, which is equal to 0. Substituting m values and n values, we get as, here m of x comma y is this, that is y cos x plus sin y plus y into dx plus, here terms which does not contain x in n means here this is our n, excluding x value means here also sin x, so we have to neglect this value. Here also x term, so neglect this value. Here also x term. So in n there is no values that does not contain x. Hence in the place of this we can substitute as 0 into dy, which is equal to 0. Now integrating these values, we get as, here integrating this equation with respect to x means here y is constant into integration of cos x is sin x plus sin y is constant into 1. Here integration of 1 with respect to x is x plus y is constant into 1, that is integration of 1 with respect to x is x. Here this value becomes c, which is equal to c. Hence we can conclude that this is a solution for the given differential equation. This completes the problem. Here is the another problem. Solve 1 plus log x plus log y into dx plus 1 plus x by y into dy, which is equal to 0. Here this is the equation which is of the form m dx plus n dy, which is equal to 0, where m is 1 plus log x plus log y and n value is 1 plus x by y. Here this is already of the form m dx plus n dy, which is equal to 0, where m is 1 plus log x plus log y, n is 1 plus x by y. Then find del m by del y value, which is equal to, here we have to partially differentiate m with respect to y. Here no y term, so here also no y term. Here we have log y. Differentiation of log y is 1 by y. That is our del m by del y. Similarly, del n by del x is, here differentiation of 1 is 0 plus here x by y. Here 1 by y is constant, take as it is, into differentiation of x is 1. Hence we get del n by del x value is also equal to 1 by y. Therefore, we can conclude del m by del y which is equal to del n by del x. This implies the given differential equation is exact differential equation. Once we conclude the equation is exact differential equation, then the solution for exact differential equation is given by the formula integral of m of x comma y into dx plus integral of terms which does not contain x in n into dy which is equal to 0. Here, this is a very important step. Substituting values of m and the terms of n which does not contain x, this is a very important step actually. M of x comma y into dx is, here m value is 1 plus log x plus log y into dx plus, here terms which does not contain x in n. Here n is 1 plus x by y. Here we have no x term. Here we have x term. So neglecting this value, substitute this value as 1 into dy which is equal to 0. Next step, integrating these equations separately and apply by integration parts rule, we have integral of uv into dx, that is, consider u as first function and v as second function. We get as first function into integral of second function into dx minus integral of d by dx of first function into integral of second function into dx into dx. Applying integration by parts rule over here, we get as, here take as this integral of 1 dx plus, here consider log x as first function and 1 as second function. So that first function into integral of 1 into dx minus integral of d by dx of first function, that is log x, into integral of 1 dx whole of dx plus integral of log y dx plus integral of 1 into dy which is equal to 0 as it is. Now integrating the terms, we get as, here integral of 1 into dx, we have to integrate this 1 with respect to dx, means that is x, plus log x into, here also integral of 1 dx is x, minus integral of, here d by dx of log x is, derivative of log x is nothing but 1 by x, into integral of 1 dx is x into dx as it is, plus here integral of log y into dx, here log y is constant, take as this, into integral of 1 dx is x plus integral of 1 into dy is y which is equal to c. Here x and x gets cancelled, the remaining is minus integral of 1 dx. We know that integral of 1 dx with respect to x is x, hence we get here plus x, here we have minus x. So cancelling plus x and minus x, the remaining is x into log x plus, here x into log y plus y which is equal to c. The remaining is this. Understand, here x and x gets cancelled, the remaining is minus integral of 1 dx. Integral of 1 dx is nothing but x, hence we have plus x and minus x gets cancelled, the remaining is x into log x plus x into log y plus y which is equal to c. Hence considering x as common over here, the remaining is x into log x plus log y plus y which is equal to c. This is a solution for the given differential equation. This completes the problem. Here we have another problem. Solve 1 plus e power x by y into dx plus e power x by y into 1 minus x by y into dy which is equal to 0. Here the given equation is of the form m dx plus n dy which is equal to 0, where m is 1 plus e power x by y and n is e power x by y into 1 minus x by y. Find del m by del y and del n by del x. Here del m by del y is partial derivative of m with respect to y. Here no y term, so neglect this value. Here we have y term. So differentiation of e power x by y is e power x by y into, again we have to differentiate this x by y term. So x is constant, take as this, into differentiation of 1 by y is minus 1 by y square. This is of del m by del y. Similarly, del n by del x is, here take e power x by y as first function and 1 minus x by y as second function, we get as first function, that is e power x by y, into differentiation of second function, that is here no x term, minus here x by y, here 1 by y is constant, take as this, that is minus 1 by is constant, take as this, into differentiation of x is 1, plus second function, that is 1 minus x by y, into differentiation of e power x by y is e power x by y, into, again we have to differentiate this x by y with respect to x, that is 1 by y is constant, differentiation of x is 1. Here multiplying e power x by y into 1 by y inside the bracket and simplify, we get as e power x by y into minus 1 by y, that is minus e power x by y divided by y, plus 1 into this term, that is plus e power x by y into 1 by y, plus into minus e power x by y into x divided by y into y is y square. So we can cancel this first terms. Hence the remaining is minus x into e power x by y divided by y square. This is same as that of del m by del y. Therefore, del m by del y value which is equal to del n by del x. This concludes the given differential equation is exact differential equation. Once you obtain the exact differential equation, solution for the exact differential equation is integral of m of x comma y into dx plus integral of terms which does not contain x in n into dy which is equal to 0. Substituting the values here, we get as integral of m of x comma y is this m value is 1 plus e power x by y plus integral of n value, that is n terms which does not contain x. Here this is our n value which contains x. Therefore, in the place of this we can substitute as 0 into dy which is equal to 0. Simplifying the integration, we get as an integration of 1 with respect to x is x plus here integration of e power x by y. This is of the form integration of e power ax. So integration of e power ax is e power ax divided by a. So we can conclude that integration of e power x by y with respect to x is e power x by y divided by here a value is 1 by y. Here this is of the form e power ax. Here a is nothing but 1 by y. So in the place of a substitute 1 by y which is equal to c. Taking y in the numerator, we get as x plus y into e power x by y which is equal to c. This is the solution for the given problem. This completes the problem. Till here we study about important question paper problems on exact differential equation. In next video we study about reducible to exact differential equation. If there is any doubts regarding this topic, comment below. Hope you all like the video. Thank you.